Okay, here we go. Here's part two. This time we're going to talk about the characteristics of a quadratic function and how you can use a graph and how you can use the actual function to determine these key features or characteristics of a quadratic function so that eventually you could graph a quadratic function by yourself using all of these characteristics. So the first thing we want to talk about is whether the quadratic opens upwards or downwards on a graph. Here's what you need to know. If it's opening upwards like this, like a U, this is a positive parabola. And in a second, I'm going to add on to that after we talk about a function and determining how the opening of the parabola is. If a parabola faces downwards like this, like a frown face or like an upside down U, it's called a negative parabola. All right, so if you're just looking at the shape, you can determine whether or not it's a positive or a negative parabola just by looking at whether it's opening up or down. But even more importantly, you could determine what the first coefficient of the quadratic is, or the quadratic term. This is called a quadratic term because it's to the second power, right? So the quadratic term here, this tells me that if it's opening upwards, that the first term, the quadratic term, is positive. If it was facing down like this term right here would actually be a negative, okay? There are three values here, 1, 2, 3, right? This is actually called the A value. This is called the B value. This is called the C value, and it's referencing actually the coefficient. So the A value of this quadratic function here is actually 1. The B value of this quadratic function is 2, and the C value of this quadratic function is -8. This will be really important as we move through the board or through your worksheet. So we'll put those notes in here so that you can see them. So if a parabola is positive, opening upwards, it means that the A value right here is also positive. If it's opening down like this, it actually indicates to me that this A value here is not a positive coefficient or a positive number out in front, but it would be a negative number out in front. So, if I'm using a function, if I'm just looking at this, I'm going to put a note down here. I'm going to say, if it opens upwards like this, it means that the A value is positive. If it is opening downwards like this, that tells me that that A value is negative. Okay? So if it opens up, it's positive. It means the A value is positive. If it's opening down, it means that it's negative and that the A value would be a negative number. Good. That's the easiest part. The axis of symmetry. If I'm looking at a graph, and I'm actually going to reference this graph and this function down here as we work through these characteristics. On a graph, the axis of symmetry is a line that passes right through that center point or the very middle of the parabola. And it passes through this turning point right here. So this is my axis of symmetry right here. It's really an invisible line, but we draw it in with a broken line like this just so that we can see where it lies on the graph. And what I see is that it crosses this x-axis. It crosses at -1. So if I'm looking at a graph and I'm trying to identify the axis of symmetry, right? It crosses the x-axis at -1. It's the very middle of the parabola, and it passes through that turning point, or the highest or lowest point of the parabola. So on a graph, I'm going to say it cuts the parabola in half. And whenever I write this, I write x equals, because I'm talking about where it's crossing the x-axis. So I'm going to write x equals, it crosses at -1. Pretty easy, right? Not hard at all. If I'm looking at a function like I'm looking right here, I have to actually use a formula or a rule to figure out what the axis of symmetry is. But it's not hard because it's just substituting numbers in, no big deal. I'm going to give you the formula for this. It's actually the x, or where it's going to cross the x-axis, is equal to negative b over 2 times a. So remember I said to you it's going to be important to be able to identify the a, b, and c value of a quadratic function. Now you can see why, because I'm going to have to substitute in a b value, and I'm going to have to substitute in an a value. So I'm going to go down here and actually use this quadratic function, and I'm going to apply this formula for it so that I can find the axis of symmetry. I'm going to go like this. A, little o, capital S. That stands for axis of symmetry, so you don't have to write out that big long word every time. I'm going to actually rewrite my formula right here in my rule to find the axis of symmetry. It's figuring out where it crosses the x-axis, and the rule is negative b over 2a. So now what I'm going to do is, I'm going to move over to this side so you can see better. I'm going to actually identify the a, the b, and the c values. So the a value is always the coefficient on the x squared, or the quadratic term. So my a value for this quadratic function is actually 1. My b value is always my linear term, or the term that has just a plain x that's to a first power, right? It's usually the middle term. So it's this term right here, and it's just the coefficient. My b value is 2. And then my last value is my c value. This is the constant, the number that doesn't have a variable at all. That's called a constant. That value is negative 8. So I'm going to use these values to substitute into this rule so that I can find the axis of symmetry for this quadratic function. So I'm just going to plug them in. I have x equals, see that negative sign that's part of the formula? That's there no matter what. That's the first thing I'm going to write down, is that negative sign, because I don't want to leave it out. The value of b is 2, so I'm going to plug that in place of the b. And then it's over 2 times whatever the a value is, and my a value is 1. And now I'm just going to do what it says. It's negative 2 over 2 times 1 is 2. And then I can actually reduce this, right? Negative 2 divided by 2 is negative 1. So now I know my axis of symmetry, or the line that would cut my parabola in half, is at negative 1. Here it is right here. It's drawn in at negative 1. All right, let's go over here to the vertex. On the graph, the vertex is pretty easy to find. It's the turning point of the parabola, right? It's where the parabola may come down. It hits the very bottom of where it's going to go, can't go any further, and then it turns around and comes back up. That's called the vertex. It also lies on the axis of symmetry. So the axis of symmetry is really important because it's going to go right through the vertex, cut the parabola in half, and here's my vertex, my turning point. So I'm going to put that over here. I'm going to put vertex here because we're going to find it in 1 second. On this graph, I can see that this is at negative 1, and then it's down 1, 2, 3, 4, 5, 6, 7, 8, 9. So my vertex is at negative 1, negative 9. On the graph, it was pretty easy to find. That's where it's at physically, but I'm going to write a little definition or a little reminder here that is the turning point on the graph. Okay, so it's the turning point. There it is. In the function, I have to do a little bit of work to find the vertex. If I don't have a graph to look at, because I'm not going to always have one, I'm going to have to do a little bit of work in order to find the vertex. I'm actually going to erase this and move it up because I'm not going to have enough room to work in that bottom right corner. Okay, if I'm looking for the vertex in a function, this is what it is. It's actually my axis of symmetry, right? Because remember we said when you find the axis of symmetry, it's an x equals, right? And when I have a point, it has an x value and it has a y value. So you've already found the x value, or the x part of this point that I'm looking for, which is the vertex, right? So I'm going to take the axis of symmetry and use it. Right here is my x value. But then I'm going to also use it because if I know what the value of x is, I can easily find the value of y. If I know what these values are, I'm just going to take it, plug it into these x's, and then it'll tell me what the value of y is. So over here I'm going to write AOS, and then to find the y value, I'm going to plug in the axis of symmetry. So this says my my axis of symmetry from over here is the first part of my vertex. To find the second part, I take my axis of symmetry and I plug it into the function that I have. I'm actually going to do that right here in this box because I just don't have enough room down there and I think you won't be able to see me writing, so bear with me. This is what the quadratic function is. It is y equals x squared plus 2x minus 8. So I said I know what the x value is. I got it over here. It's -1. I'm looking for the y value. So I'm going to plug this -1 in wherever I see an x because this told me over here that my x is -1. So here's what I have. Y equals, taking out the x, plugging in a -1, squared plus 2, taking out the x, plugging in a -1. I'm going to continue solving this. So this is y equals -1 squared is +1. 2 times -1 is -2, and then I have a minus 8. And I'm going to finish this off. 1 minus 2 is -1. -1 minus 8 is -9. So now I found the y part of my vertex. Pretty easy. Found my axis of symmetry, plugged it in, and got my y value. Now I have my vertex. Come over down here into this bottom left-hand corner. I'm looking at what's called a minimum and a maximum. If something is a minimum or a minimum value, it means it's the smallest amount or the lowest point on a graph. So the only time I would have a minimum is if the graph was facing upwards like this. It's going to have a lowest point on the graph, so it's called a minimum. Or you might have a maximum. A maximum would be the most or the highest point of the graph. It can't go any higher than that maximum point. So you're only going to have a maximum if your graph is opening downwards or it's negative, okay? So if I'm looking at a graph, the minimum is the lowest point. If I'm looking at a graph and I'm trying to see if it has a maximum, it's the highest point. Okay? If I'm looking at the function, we already can determine whether or not something is upwards or downwards, if it's facing up or down, by looking at the a value. So here's what I'm going to say. If you have a minimum, it means that your a value, let's go back and think about this. If it has a minimum, it means it has a lowest point, right? So that means that the a value of the function had to have been positive. So you're going to have a minimum if the a value is positive. You'll have a max or a maximum value if your a value, let's go back and look. If you have a maximum, it means it has a highest point. That means that the parabola has to be opening upside down like this. And we already determined that if you have an upside down parabola like this, it tells you that the a value is negative. So if you have a max value, it means that your a value is negative. All right, last part, but this is actually super easy. If I'm looking for the zeros on a graph, the zeros are the places where the parabola actually touches or crosses or intersects the x-axis. So here we go right here. Boom, boom. My parabola is crossing, hitting, intersecting the x-axis at 2 points. The first place it intersects at is at -4. The second place it intersects at is +2. So on the graph, I have x-intercepts, or I won't call them that. We'll just call them the zeros for now. I have zeros at -4 and +2. I'm always going to include the word "and" there. I'm never going to put a comma, because if I put a comma, this does not look like x-intercepts. This looks like a point at -4, +2. So I don't want to do that because that does not indicate what I really want to indicate. So I'm going to put the word "and" between the two places that I find my parabola crossing the x-axis. And that's called, those are the zeros. The domain and range. Domain has to do with all the x values that this parabola will cover. So I'm going to tell you that your domain is going to be the same every single time you look at a parabola. A parabola, as it opens up, it expands and it grows and it goes on forever and ever and ever. It never stops. So eventually it's going to hit every single x-axis that you could possibly think of, because numbers go into infinity and I can't name them all. But what I can do is use a symbol to represent that. We're going to say that it's all real numbers. You can write out all real numbers if you want to, or you can use that symbol, and I'm pretty sure we've used this symbol before. It's just two straight lines and then a giant, looks like a giant R. Okay? For the range, it's a little different. We're going to talk about all the y values, right? So where the parabola, how far it goes up or how far it goes down. Let's look at this parabola right here. For this one, if I'm trying to talk about all the y values that this parabola will ever touch or ever encompass, this one has a minimum or a low point, right? A lowest point on the graph. So I'm going to say all the y values are never going to go below this point. This is like a stop sign. It's like a brick wall. The parabola will never cross here. So this is actually a lowest point. That means that all my y values, they will never be less than this. They will all be greater than or larger than this. So on here I'm going to say the y values for this are greater than or equal to, and where's that point at on the y-axis? It's down at -9. And that's it. All my y values will be greater than or equal to -9. Because the graph opens upwards, all the values are going to be greater than. If this parabola actually opened downwards, like this, instead of saying the y values are greater than, I would say the y values are less than, because they're all below that point, or less than, okay? You can actually help yourself, because this number right here will always be the same as the y value from your vertex. So, pretty cool to know. The x value from your x-axis of symmetry is the x value in your vertex. And the y value from your vertex is actually the y value in your range. All right, listen, this is a lot. It's a lot of information at once, and I know that, but you can go back and rewatch this video 100 times if you want. Or you can email questions. You can post a question below this video in your Google Classroom, or you can send us a question via Remind, and one of us will get back to you as quickly as we can to make sure that you're on target and that you understand what you're doing. We're going to post another video later in the week that does an actual review before we do some sort of assessment at the end of this week, okay? So go back, rewatch the videos, post any questions you have. We are here for you, I promise. Again, you can email, you can text through Remind, or you can leave a message in Google Classroom right below the lesson, or you can private message through there, okay? All right, guys, stay safe, stay healthy. We actually miss you a ton. We really do. It's really not that much fun to just teach my dog. But hopefully I'll see you soon. Take care.